Earth's core has reversed its rotation. What does that mean for us? As early as 2024, scientists from the US and China discovered that the Earth's core had slowed down and even stopped moving in relation to the Earth's crust. But until now, the general public, that's people like you and me, has barely noticed this remarkable change. The Earth's core is comprised of metals and, as the name suggests, makes up the interior of the Earth. It consists of a liquid outer core, made of iron and nickel and other elements which play a role in the Earth's magnetic field, and a solid inner core, also made of iron and nickel at a temperature up to 5,700 degrees Celsius. The Earth's outer core begins around 1,800 miles below the Earth's surface, and the inner core begins around 3,200 miles below. For a long time, scientists assumed that the Earth's inner core had a stable, even and constant rotation below the Earth's crust. However, with the help of seismic analyses, that is, studies of earthquakes, researchers have discovered that this rotation is by no means constant, but fluctuates. These fluctuations can be so massive that the Earth's core can move as fast as the Earth's crust, and then appear to stand still. However, this doesn't mean that the Earth's core rotates in the opposite direction. Instead, it only appears that way because it rotates more slowly in relation to the Earth's crust, sometimes even significantly more slowly. Nor does the Earth's core ever remain stationary but simply stops changing in relation to the Earth's crust. This current slowdown in the rotation of the Earth's core began as early as 2009. At that time, the Earth's core and crust moved more or less in unison, but since then the movement of the Earth's core has become even slower. It seems that the Earth's core changes its rotational direction relative to the Earth's crust every 35 years. Therefore, the fluctuations that comprise an entire cycle last 70 years. What effects does this have on Earth? Technically, days can become longer or shorter due to the changes in rotational speed of the Earth's core. However, the changes are tiny, in the range of milliseconds. We humans might not notice this, but it can have an effect on astronomical measurements and satellites. Changes to the Earth's magnetic field and the climate are also possible.